across probably at some point in one of your classes, you know, whether it be in high school, you kind of touched on it in like Math 3, and then kind of moving on in college algebra probably a little bit. So we're just going to kind of do a quick review of these. I would highly recommend writing these down. One of the main things we're looking out of this is not just being able to find the answer, being able to identify what rule you're actually going to use. So, you know, is it going to be the product rule? Are you going to have the same base? So in the product rule, we'll notice here is that you take a look at this base A and A. So let's review this real quickly. So B would be my base. All right, so B is the base. And then let's go X is the exponent. So, and in this case here, we can say like Y, and Y would be our solution. All right, so when we look at this, what we're saying is our bases are the same. So if our bases are the same, then we can add our exponents. Or the quotient rule, if your bases are the same, then you can subtract your exponents. This rule essentially is kind of like looking and saying, like, if I had a squared over a to the first, then I can see that I have more on top. So it's almost like thinking about canceling and saying, okay, a's and a's cancel, it leaves me with 1. Same thing here. You're just adding them up. You're saying how many total do I have? The difference is that when we apply the power rules, so we have the power rule of multiplication, and that is going to be a situation where we're multiplying the exponents together. Or in the quotient rule of the power rules, you are going to distribute the exponent to both of the values inside the parentheses. All right, so kind of a quick run through, and let's jump into some problems. So these guys have the answers with them. And so what I want us to focus on is, let's focus on the name. All right, so we start off and we have one with a negative exponent. So we cruise back up to our rules and we see that, oh, we got this special rule right here, and that's going to be our negative exponent. So our name of this property would be our negative exponent. All right, and then kind of take a second here and let's go back and forth. So I would highly recommend, I'm going to go just up real quick. I would highly recommend that you take a second and write down these rules, or find them, take a screenshot out of the book, because these are definitely rules that, I'm not out of the book, excuse me, but definitely write those down and have those as a tool inside of like your notes that you're going to use for your tests and so forth, or for the homework. All right, so hit pause, get those written down. When you're ready, come on back. So the next one, we take a look at this guy, and this is one interesting way that we could work this. But take a second and let's kind of like say, all right, what rule could we apply to this problem? All right, so I probably wouldn't have done this problem this way, but that works. I would have looked at this problem possibly and said, okay, well, let's get the bases the same. Let's do it the way they did it first. So in this case here, all they did was apply the negative exponent. So negative exponent, so that means that this was 2 to the negative first. This now becomes 2 to the 1 over 2 to the positive 1 and 1 over 4 to the positive 1. And then at that point, to be able to do this, we have to get a common denominator, right? So this becomes 2/4 plus 1/4, which gives us 3/4. Now, the way that I would have maybe thought about this question is that I would have said, I would have looked at something similar to a like base situation. So like, for example, this guy right here. So if I can make the bases the same, then I can add my exponents, and then I can solve it from there. Or another way is that if I can make it so, yeah, I think that's the main thing. If I can make it so my bases are the same, I can go from there. So what I would say is I'd be like, okay, well, I've got 2 to the negative first power plus 4 to the negative first power. I wonder if I can make this into a 2. Let's think about that. 4 squared is equal to, 2 squared is equal to 4. So this is essentially 2 to the negative 1 plus 2 squared raised to the negative first power. So I just simplified to get like bases. So now essentially what I have is I have 2 to the negative 1 plus 2 to the negative 2. And then at that point, I look back through my rules, and let's see, do we have anything that has addition in it? Oh, we don't. So that doesn't really do me a ton of good, because now here I am sitting with a situation where, if I think about it, I basically have what I started with, which is 1/2 plus 1/4. So in actuality, it actually would have been better to go actually with the way they did. So interesting how you work through that sometimes, and then you realize, oh, I was actually off by a little bit. All right. So same thing. If you want to try to work ahead on your own, work ahead and hit pause, work ahead, hit play to check your work, and I'll be here kind of working on them. All right. Number 3. So let's see what we got here. So we've got these situations where we've got the negative exponent, right? So with the properties of negative exponent, basically what it's saying when I break this down, so 10 to the negative second over 10 to the negative third, basically what's happening here is that essentially what I could do, and it's not going to do me any good, I could just flippity flop that around. Now, I like that they just went ahead and brought this up though, because with a little simplification, what they realized is that instead of just like flopping it around and then doing 10 to the 3 minus 2, because that would be our quotient rule, because the bases are the same, right? So we subtract our exponents. So instead of just doing that right off and kind of manipulating the problem to be friendly numbers, subtracting it and 10 to the first, instead they just jump right into it. They're just like, okay, well, I know that I can leave the negative 2 on top. I know I can bring this negative 3 exponent up, and I can subtract it, because if we have one on the bottom, one on the top, with the like bases, we can subtract those 2 exponents. Well, the thing about that is that creates like this crazy negative situation. So we simplify this. This becomes 10 to the negative 2 plus 3, which becomes 10 to the first, which is nothing more than 10. So a couple different ways to work our ways around this. Basically, we're using the quotient rule. And then in this case right here, we're using the product rule. So I'm getting a little bit of lag. So then we're using the product rule. All right, and that product rule leads us to plain old simplification. All right, so if you want to hit, like I said, do the same thing, hit pause, come back when you're ready. I'll be right here working these. Okay, the next one. So we have the negative exponent. So one way that maybe think about this to understand, so this is a negative exponent. So one way to think about this to kind of understand is we are actually going to distribute that negative to everything inside. So then, because this is negative and the bases are not the same, there's no way to make 3 and 8 the same. If we have a negative exponent, then that's going to come to the top, and that will become 8 to the third. That's negative exponent, so that's going to go to the bottom, so that becomes 3 to the third. At this point, because of the fact that there's really nothing we can do, there's no like bases, we have to have like bases to be able to simplify anything. So we're just using negative exponents, we're done. Because there's nothing that can be simplified. We can take 8 to the third power, and we do that, we get 8 raised to the third power. We find out that's 512 over 27. I take 512, I divide it by 27, and I get some big nasty decimal that I don't really care about. I get 18.96 ... So this is my best answer. And honestly, that's my best answer, because that's simplified as much as possible. All right, one more of these. All right, so we've got 2 to the negative 3 times negative 4. So we look up and we realize this is the power rules, one of the power rules. And so that in this case here, we have a base with a power raised to a power. We take those powers and we multiply them together. And so in this case right here, you can see that they put them together, simplified, and got 2 to the 12. So this is the power property. All right. These problems are actually on your homework. So we'll just go ahead and go with that. You're doing the odds on that page in the homework. So don't worry about it. It says the ticket out the door. That was because when this is used as an in-class situation.